I forget most. And which unit do you want to look at?
Could we do 3?
Mm-hmm. This is actually the most effective way to do it, rather than have you verbalize these problems or send me a picture of them. This actually is the quickest, easiest.
And then there should be one making money. I think it's more towards the bottom.
I see it. Making money worksheet?
Yeah.
Okay. Okay. Have they taught you just one formula? There's 3.
Yeah.
There's 3 different ways you can compound money. Annually, once a year. More often than annually, like once a month or every day. And the third way is continuous, where it's continuously compounding every single second.
I think that we've done all 3.
You've done all 3?
Yeah.
Okay. Let's list the equations over here on the left for all 3. And then we'll see which one applies for each of these problems. I love to start all math problems with the standard format. So if you're going annually, hold on, I'm going to have to do this a little different. So for annual, A is equal to what?
Isn't it?
Your starting amount, called A sub 0.
And then parentheses 1 minus.
It's 1 plus your interest, which is R, all to the number of years. Okay? In other words, if you were earning 6% on your money compounded annually for 5 years, this would be 1.06 to the 5th power times the amount you started with. Okay? Greater than annual, meaning any time period that's more frequent than annual, like monthly would be more frequent. Okay?
Okay.
Then in that case, A is equal to A sub 0 times 1 plus R divided by, use K or N?
We usually use N.
All to the NT. And what that means is, let's say you were earning 6% on your money for 5 years, but it was being compounded every month. N is the number of times per year that it's being compounded. So up here, it would be A sub 0 times 1.06 to the 5th if it was for 5 years. But if you were compounding it every month, it would be whatever you started with times 1 plus 0.06 divided by 12, because N is 12, times 12 times 5 years. And you get all of these out of your calculator. This number here is just going to be marginally bigger than this number here, despite what it looks like. In other words, you're taking this thing to the 60th power, but you're taking a relatively small number to the 60th power. Notice that this is 1.06 to the 5th power, and this is going to be like 1.005 to the 60th power. Well, those two numbers are actually quite similar. Okay, and then the way most of the world works is continuous compounding. Everything in nature These first two were kind of created by humans. Nothing in nature compounds once a year or once a month even. But most things in nature do their, like if you're talking about bacterial growth, that compounds continuously. And that A is equal to E to the R, or A sub 0, your starting amount, times E to the RT, where E is Euler's constant, or Euler's constant.
Yeah, I don't think we've learned the last one yet.
The last one. Okay, well, let's erase that. Yeah, they probably haven't taught you about E yet. E is that number that's 2.71 approximately.
Yeah, we have not learned about that yet.
The reason that number is such an important number in math is because it's part of that continuous growth. And everything in the world is either continuous growth or continuous decay. If you're looking at uranium and it's decaying, it decays based on that A equals E to the RT. So E is probably the second most important number in all of math after pi, because it figures in so many real-life processes. Anything that's growing or decaying at a rate based on how much is there involves E.
Okay.
All right, so here's our two equations. Let me erase the examples just so that I don't confuse you, and let's use their questions and amounts. Okay, so let's fill out this table. She invests $200 in each bank. This earns 10% per year. So how much does she have after 2 years? Give me the equation. We're going to use equation number 1 instead of 2. Okay. So the amount she will have after 2 years is her starting amount. Give me the rest. What's the rest of it?
Would it be 200 and then 1 plus 20?
No.
Oh, no.
1 plus 0.1.
Yeah.
In other words, R here is 10%, but you got to convert that to a decimal. So it's 0.1. Okay. So that would be 1.1. To what power?
Would it just be 1 because it's per year?
No, T is the number of years. So it's 2. Okay. Do you have a calculator?
Yeah.
Take 1.1, square it, multiply it by itself, whatever, and multiply that by 200. What do you get?
$242.
How much?
242.
Okay, now cube it. Because the third year, the only thing that changes is this 3. T changes to 3. Can you easily cube it and multiply it?
So 2.66.20.
So $266, rounded off. Now let's go over and do a couple calculations on the other side. We could continue on, and the only thing to finish the left side, you got to do it to the 4th power, and then you got to do it to the 5th power. And that's what goes on the left side in the last 2 spaces. Okay, let's go up here and do the right column. So how much do you have after 1 year?
200. Oh, no. So then would it be 200 parentheses 1.8 to the power of 1?
Not 0.8. It's 0.08. So it's going to be 200, your starting amount, times 1.08. Hold on a second. Jesus, I messed this whole thing up. Let me go back. The right column is with compounded interest. So the right column needs to use that formula we were just using on the left column. Okay? So the right column, the first year you make 8%, and then we have to fill in the rest. Let's go back on the left column. Because it's not compounded, you only earn $20 a year. So that becomes $240, $260, $280, $300. Or you're earning a flat $20 per year based on the $200 original investment. I don't like that because nobody does it that way. Compound interest at 8% a year. Okay, the first number we need is 1.08 squared. Give me what that is, and then multiply it by 200.
So 1.08 squared is 1.1664.
I'll multiply that by 200. Did you do 1.08 squared?
I think so. Yeah.
Okay, multiply by 200, what do you get?
233.28.
Okay, I'm going to round it off to dollars. Now, let's figure out what you get after 3 years. Take 1.08 and cube it, and then multiply that by $200.
$252.
Now do the same thing after 4 years. Take it to the 4th power. You know how to do that on your calculator using the arrow key?
Yeah.
Okay.
So 272.
And finally to the 5th power.
$294.
So if you knew you were going to leave it in there for 5 years, which one would you take?
The first one.
Yeah, but you can kind of see that after 6 years, the one on the right's going to be bigger.
Yeah.
In other words, as we go further into the future, compounding makes the fact that it's almost the same after 5 years is pretty astounding, considering it's 8% compared to 10%. The difference is the compounding. In other words, in this one, the second year, we're earning 8% on 208. And in the third year, we're earning 8% on 233. Whereas in the first case, we're earning 10% on 1000, 10% that year, 10% on 1000 that year, 10% on, 200. So you're only earning $20 a year in interest.
Uh-huh.
There ain't no bank in the world that has that. Every bank has a minimum of compounded yearly. Nobody offers this. Nobody would take that. Okay, so I need to scroll down here. So, which graph represents the left column?
Would it be the C?
No, it's linear. In other words, it went up by the same, the slope is the same. The thing isn't working. Just a second. I'll get it working. In other words, it went 240, 260, 280, 300. That's a constant slope. That is a straight line. When I go over 1, I go up 20. When I go over 1 again, I go up 20. I got a slope of 20. Okay? That's a straight line, which is what that is. So the column on the left is this. Remember, the other one is an exponential. It's 1.08 to the t. So as t increases, you got to, in other words, when your variable is in the exponent, it looks like an exponential graph. Well, which graph looks exponential?
A?
Yeah. Exponential graphs go like that. This over here looks more like square root graph or some sort of a logarithm graph. But it's not either of those columns. Okay, so we answered these already, yeah. Yeah, no, I think we got it right. And C doesn't have, that's a good description of the first one. Notice that is $200. Starts at $200 in every case. So this point is 200. This point's 200. This point's 200. Notice that at annual, it's linear, so it just goes up by the same constant amount every year. Whereas with our compounded interest, the second year the growth is a little faster because you're compounding. You're earning interest on the interest also that you earned in the first year. You're not just earning interest on the $200, you're earning interest on the $200 plus the 8% you made.
Uh-huh.
You know what? We didn't write the right numbers down. Our first number we wrote down was 208. It should have been 216. Here, let's go back and visit that because I think that makes a difference on the bottom line. That should be 216 right there. We didn't have it as that, did we? I think we had it as 208.
Yeah, we had it as 208.
But all the other numbers should have been right. I think I did that in my head to write 208, and I made a mistake. Yeah, the second one, you have to do 1.08 squared times 200. And I think we did all of those correctly. But year one would have not been correct. All right, let's scroll down here and see what else we got. That's all we know. Okay, what's that formula again?
A to the 0 on the bottom, parentheses 1 plus r to the power of t.
So A equals A sub 0. No, we can do more than that. A equals 200 times what?
1 plus r.
Yeah, you can write it as 1.08 because we have all the specifics.
Then to the power of
n, which is a little upsetting because they should use t. Because n is used as the denominator when you're doing it more often than once a year. Although I'm not sure they're going to ask you about that. I have a feeling the only formula they're really working with is this one. So far, we haven't seen one that is compounded more often than once a year. What's the formula for the bank that just pays 10% simple interest?
Is it the a to the 0 parentheses 1 plus r over n?
No, because all three of those formulas that I wrote down for you are all based on compounding interest. Because that's real life. There's nobody that has just straight simple interest. But what did we do? We earned $20 per year, right? So
Yeah.
so it's plus 20 times n. Notice that that is an algebraic, and that is a linear equation. There's nothing being squared. I don't have a variable in the exponent. That's just a straight linear equation of the form y equal mx plus b. I want to write it as y equal mx plus b. I'll write it as a equals 20n plus 200. That's a straight line. This over here is not an algebraic equation. When your variable is in the exponent, it's an exponential equation, which is a lot different because you really don't have any way to solve exponential equations without logarithms. I'll give you an example. 2 cubed equals 8, correct? Correct?
You just cut out.
2 cubed equals 8.
Oh, yeah.
What do I say? What exponent would cause 2 to that exponent to equal to 7? Would you have any way to figure that out?
Would it be like...
You cannot do it algebraically. There's no algebraic solution. It's not an algebraic equation. So the only way to figure that out is by using logarithms. Now, you got to be getting close to logs because these exponential growth problems like this, that's an exponential equation there. That's not an algebraic equation. So the only way to solve some of those, it's easy enough if they give you the exponent, but if you're solving for the exponent, say they take this problem that we're looking at, and they say, how long will it take your $200 to grow to $400? So I would write it like this. Okay? There's only one variable in that, and that's the exponent. And so you would not have any way to solve that. But once you learn logarithms, you can solve it. It's quite simple after you learn logs. Have they not taught you logs yet?
No, not yet.
I'll bet you it's coming up next semester, probably first thing. You're not getting any new material for this semester, are you? This is all just review, right?
Yeah.
Okay. So there's no way it could be this semester since it's almost over. Okay.
Yeah, I have my final tomorrow, and then we go into Christmas break. So.
Okay. So the one on the left was an algebraic linear equation, and this was an exponential equation. And we listed both of them. Okay, Mary wants to invest some money for 5 years or more. Which bank should she choose? Give full reasons for your answer. Well, assuming our numbers were correct, if she invested for exactly 5 years, she'd have been better off with the first bank, paying 10%. But you can see that the bank paying 8% compounded annually was increasing faster and almost had caught up after 5 years. Well, I bet anything that if you did 6 years, it would be greater. And the more years you do, the greater it's going to be. So in a little You might want to check those numbers if you have to turn this in, or is this just for your edification for reviewing for the final?
It's just for reviewing.
Okay. Assuming we had the numbers correct, after 5 years, one was at 300, one was at like 293, right?
Yeah.
So if it was for 5 years or more, that's an ambiguous question, because if it, maybe that's what you should say. If it's 5 years exactly, bank number 1. If it's more than 5 years, bank number 2.
Yeah.
And that's what you can say in your answer. Give full reasons for your answer. And yeah, it's as simple as that. Now, it may not be 6 years. We didn't do 6 years to see whether the compounded surpassed the other one. But certainly at 7 years it would, I'm quite certain. So I don't know. That's kind of a funky question. It almost makes me think that we did our math wrong. Maybe. This would almost indicate that at the end of 5 years, the 8% bank would have been more. Otherwise, you get 2 different answers. In other words, if you can only pick one bank for 5 or more years, depends on whether it's 5 years, 6 years, or 7 years. Anyway.
Right.
Got any last questions before your final?
I don't think so.
Okay. Ellie, good luck on your final, and have a good holidays, and maybe I will talk to you next semester.
Yes, thank you so much.
You're welcome. Good night.
Good night.